there! Subscribe, you bitch!
Let's start with Venus. Venus is the nearest planet to Earth, only about 40 million kilometers away, meaning the trip wouldn't take long, roughly 4 months. Its size and gravitational pull are close to Earth's, so those wouldn't be major obstacles. Your first big problem would be the thick yellow clouds you'd notice as you draw closer to the surface. Sadly, these clouds are made of sulfuric acid, a dangerous chemical that would destroy your lungs instantly. But let's assume your suit has filters designed to handle it. As you start descending, visibility would fade quickly. The atmosphere becomes incredibly dense and is mostly carbon dioxide, limiting how far you can see. Then you'd feel the heat, a brutal 450 degrees Celsius. Because the thick atmosphere blocks most sunlight, only about 10% reaches the surface, leaving everything dim. Moving your limbs would feel nearly impossible. Even with gravity similar to Earth's, the dense air would feel like slogging through liquid. What in a strong pressurized suit might keep you alive for a moment. But it wouldn't be long before the crushing pressure, around 92 bars compared to Earth's one, destroys it. And if that somehow didn't finish you, the sulfuric acid you inhale, once the suit breaks, definitely would. Moving on to Jupiter, Jupiter is the largest planet, and it's easily one of the most dangerous to descend onto because of its intense radiation. Even from 300,000 kilometers out, that radiation would pierce your suit. But let's imagine you're wearing an advanced suit capable of shielding you. Jupiter's gravity is 2.4 times that of Earth, so you would fall at extreme speeds. Entering the atmosphere brings you into layers of white clouds made of frozen ammonia crystals, where temperatures hit around minus 150 degrees Celsius and winds can blast up to 482 kilometers per hour. If you manage to drop about 150 kilometers, you would reach the lowest depth ever reached, the point where NASA's Galileo probe was destroyed in 1995. Past that, everything becomes darker as pressure and temperature increase swiftly. Deep inside, pressure is estimated to reach 100 million times Earth's atmospheric pressure. After hours of falling, you might enter a supercritical fluid layer, a strange state between liquid and gas. Descending even deeper would bring you into metallic hydrogen, an extremely dense fluid capable of trapping you. If you somehow endured that, you'd eventually reach the core, which may or may not be solid. Temperatures there soar to nearly 24,000 degrees Celsius, about 4.5 times hotter than the surface of the sun. Next, we have Saturn. Saturn ranks as the second largest planet and has an atmosphere dominated by hydrogen and helium. The first hazard is navigating past its 146 moons. You'd have to get through its iconic rings made of broken moon pieces, icy debris, comets, and small asteroids. If you manage to survive that, you'd witness vibrant red and purple auroras created by energetic hydrogen particles. But Saturn also unleashes violent winds reaching 1,800 kilometers per hour, making stability nearly impossible. Entering from the North Pole isn't easier. You'd hit a gigantic storm large enough to hold 2 Earth's temperatures up there can sink to minus 250 degrees Celsius. As you descend deeper, temperatures rise to around 0 degrees Celsius, though the pressure becomes the primary danger, similar to the pressure at the deepest points of Earth's oceans. Go even farther and the gases around you begin transitioning into liquid form. At Saturn's core, you'd reach a molten rocky interior around 10 times Earth's size, burning at approximately 11,700 degrees Celsius, with pressures about 1,000 times greater than on Earth. Uranus is incredibly distant from Earth and belongs to the pair of planets known as ice giants. It rotates on its side and spins faster than Earth, giving it a 17-hour day. Despite its name being an ice giant doesn't imply it's a frozen solid ball. The planet is mostly composed of heavier elements rather than simple hydrogen and helium. After slipping past its rings, you'd enter layers of toxic gas. Temperatures drop sharply to below minus 220 degrees Celsius, making it the coldest planet in the solar system. As you sink further, you would be hit by pellets of ice. Eventually, you'd reach a region where actual diamond rain falls, propelled by 900 kilometers per hour winds, but the pressure, about 100 times stronger than Earth's, would eventually crush you. Neptune. Neptune is the second ice giant and the most distant planet from the Sun, lying about 30 times farther from it than Earth. Sunlight barely reaches it, leaving the planet extremely dim. Like Uranus, its outer areas are freezing cold, but deep inside the planet becomes incredibly hot due to enormous pressure. Its core temperature climbs to around 7,000 degrees Celsius, hotter than the sun's surface. High pressure deeper in the atmosphere causes methane to break apart, producing spectacular diamond rain. Neptune also produces some of the fastest winds in the solar system, often reaching supersonic speeds. In many respects, Neptune behaves almost like Uranus' twin. Mercury. Mercury is the planet closest to the Sun, but paradoxically, it isn't always scorching. At night, temperatures drop to minus 180 degrees Celsius, while during the day, they shoot up to 430 degrees Celsius. This huge difference exists because Mercury doesn't have a real atmosphere, only a thin exosphere that can't hold heat. Along with the temperature extremes, Mercury bombards you with intense solar radiation and offers no oxygen at all. It receives nearly 7 times the sunlight Earth does. Being the smallest planet makes its surface rugged and full of cliffs, craters, and rocky terrain, creating a difficult landing environment. And because the air is so thin, there's barely any drag to slow a spacecraft, increasing the risk of a crash. Landing during the day is impossible. Due to the extreme heat, modern NASA suits can handle only up to 121 degrees Celsius. Nowhere near Mercury's 430 degrees Celsius daytime temperatures. With Mercury's extremely slow rotation, a single day there lasts about half an Earth year. Nighttime is hardly safer. Minus 180 degrees Celsius goes way beyond the minus 157 degrees Celsius limit of current suits. The safest option would be attempting to land in the Terminator zone, the narrow region between day and night where temperatures are less extreme, but even there, conditions change quickly and remain dangerous. Finally, we reach Mars. Mars is the second nearest planet to Earth, and the one most suited for human survival out of the 8 planets. Daytime temperatures can reach a mild 20 degrees Celsius, much more tolerable than those on Mercury or Venus. But nights, or certain locations, can see temperatures plunge to minus 113 degrees Celsius. Mars also suffers from a very thin atmosphere, mostly carbon dioxide with only tiny amounts of oxygen. This means little breathable air, low pressure, and high exposure to radiation levels on Mars measure about 24 to 30 rads, around 40 to 50 times more than on Earth. It also experiences severe dust storms capable of reaching 100 kilometers per hour. Any effort to live on Mars would require airtight habitats, strong insulation, and a reliable life support system.